All right, good morning everyone and welcome to Office Hours with Snowflake featuring Zeeto. We're very lucky today to have Matthew Ferguson, the CTO of Zeeto, on the call. Before he presents the basic use case that they have for Snowflake and what they've been able to accomplish with the product, I'll be going through a very quick overview of Snowflake as a product in case you aren't familiar with Snowflake yet. At the very end, and the entire purpose for this entire call is to open it up for questions and answers. So as we're going along, at the bottom of your screen, you'll notice a Q&A button within the On24 platform. If you click on that, you can enter your questions as we're going along, and then we'll be able to see them at the end and go through the Q&A and answer them. With that, let's get started and talk a little bit about Snowflake. Now, what we've seen is that what people want from the database is relatively straightforward. They want something that's easy to manage. It doesn't require 15 people to be able to functionally deliver data to the business. They want to be able to put all of their data in one system. Modern organizations have data that is created in many different types of data, from structured to semi-structured. It's created for many different subsidiaries and different parts of the organization. And it'd be nice to be able to have it all in one simple system. Organizations also want to scale on demand. The cloud has given us this fantastic capability to go from a world where you have fixed capacity to being able to scale elastically to match the demand at any given time. And it'd be nice to be able to take advantage of that with a database. And of course, people want to use standard SQL skills. SQL is a language of data, and most organizations don't want to have to retrain their workforce or hire a bunch of different people to be able to use technologies like Hadoop and NoSQL that require a lot of different skills for data warehousing. Unfortunately, the current technologies that are available to us don't really enable these problems to be solved. Management can be extremely difficult with existing data warehouses and data management technologies. You have to have lots of people devoted to indexing and tuning and sorting of the database. And so management can actually take an enormous amount of time, not actually using the data that's in the database, but just making sure that it's available. Of course, it's difficult to get all of the data in a single system as well. Naturally, data comes from many different sources, and it can be hard to bring them all together. ETL processes can be challenging. Certain types of data are only able to be stored in certain types of repositories. It creates a lot of challenges that make it hard to bring data together. Of course, scaling on demand with existing technologies is also very difficult because they were designed for a time when you had fixed sets of resources. Even cloud data warehouses, supposedly cloud data warehouses, can rely on existing technology and architectures that really don't scale very well. And of course, I already mentioned the fact that there are many tools available today in the marketplace that don't use standard SQL or use a variant of SQL that doesn't really solve all of the same problems. And we know, we can't fix this with traditional architectures. We can't fix it with shared disk architecture. We can't fix it with a shared nothing architecture because they're fundamentally created for a world that wasn't focused on the cloud, where you didn't have this unlimited elastic set of resources that you could use. Snowflake delivers a completely different world. It's a next generation data warehouse that's built as a service to help you unify your data, scale effectively, and empower your team and deliver analytics. How do we do that? Well, we created a brand new architecture for data warehousing. We start with flexible cloud storage that can enable you to put all types of data, whether it's structured or semi-structured, into the same centralized repository. Around that centralized repository, we have unlimited compute clusters that you can use to serve different use cases. So if you have a data science team, they can have their own dedicated, isolated compute resource, and so can SQL queries, data transformation, and BI and reporting. The thing that's particularly interesting about this is that you can actually have multiple clusters that are focused on the same use case. This is great for BI and reporting use cases where you may have very few people who are accessing data and reports at any given time, and then on Monday morning you may have a huge rush of people. These multi-cluster warehouses will automatically scale to the right number of clusters to serve as much concurrency as your organization and your use case demands. Of course, the cloud is so powerful because it also allows us to turn off resources when we don't need them. And Snowflake, of course, enables you to turn off any of the compute resources that you don't need at any given time. On top of all of this, we have the cloud services layer, which takes care of the management, the optimization, the security, the availability that ordinarily you would have to manage on your own with a data warehouse. So when you load data into Snowflake, it's automatically optimized, indexed for you, and it's accessible at any time through standard SQL. So with that quick overview, I'm going to turn it over to Matthew, and thank you so much for joining us today. We're really happy to have you presenting, and I'm sure we're going to get a lot of interesting questions once we see your presentation.
All right, thank you very much for having me. We have been a Snowflake user now for, I think about a year, exactly a year actually. And we've had a lot of benefit, which we're going to talk about. So let me just jump right in. First thing to talk about, and you're going to have questions, is what is Zeeto and who is Zeeto? So this little diagram I'm going to walk through just to make sure everybody understands as we go into more context. So first of all, we are an ad network. So there's Zeeto in the orange, sitting between publishers, website owners, and advertisers. And publishers want to monetize their website, and they do that typically by having ads on them, whether that's a Zeeto ad tag or a Google ad tag or something else. But that's the way it's done. And we just have a special secret sauce, which is we ask questions. So instead of just showing an ad based on the type of site, we actually have a recommendation engine that identifies the attributes that need to get asked or found in order to fulfill a particular advertiser's needs. And we ask questions first to see if that user, that visitor, is able to have that attribute. And so we can real-time determine what ad to show and then ask another question. So people will engage, and some people find that hard to believe, but visitors to websites will engage and answer questions one after another. So it's a great niche. We're the only ones out in the market doing it, and we've been doing it for a number of years. So basically, we're in charge of those recommendations, serving questions, serving ads, machine learning predictions to augment the success. And then, of course, reporting to our publishers and advertisers on the success of their campaigns, as well as the revenue that the publishers would receive. So our advertisers are able to micro-target down to a very specific visitor that they want to show their ad to. So it might be, female, age 35 to 45 that has shoulder pain. Because they want to present a drug for shoulder pain or back pain or something like that. So the pharma budgets are a large component of that type of thing. So that micro-targeting can only be done through asking questions. So knowing that, what Zeeto is pretty critical. You can see we're a data company, right? We deal with millions of visitors a day. We deal with hundreds of millions of events and through our system, and we want to know how the whole thing works. So prior to Snowflake, we did have a legacy platform that we just recently converted, and it was using MySQL data warehouse. It was all written and it was all on top of AWS. So quite a bit of management and fairly rigid structure. We really wanted also to switch out of using Google Analytics, in cases where we do host publisher sites, our own sites. The Google Analytics was getting to be expensive for what we needed. So there was an opportunity to also use Snowflake to switch out Google Analytics. So these two warehouses, if you will, and analytics products were where we wanted to switch with a new platform. And the reason we wanted to do that was, number one, the company growth. We had foreseen with our new platform that we would be able to go 10x the number of visitors that we see on the platform, and that actually might be a low estimate. We were moving to a microservices events, so microservices architecture, naturally each of those microservices throwing out events, and it was real clear to us that we wanted to understand at some point in the future, what are all these events and how do we make sense of them? We also wanted to be able to do anomaly detection, and that was hard in the existing system. So being able to look at a campaign or a publisher day over day, trend things, look at linear regression, do predictions, and evaluate if we have a problem in the platform, making decisions, or for a campaign, and just how it was performing on behalf of our customers. All right, moving on. So why Snowflake? Well, Ross, you had a number of points that I'm kind of, I guess, parroting, because these were a lot of the things you just brought up. But number one, SQL compatible. We've done a lot of work with non-SQL compatible approaches in the past, whether it was putting BI connectors on top of Mongo, which we're a big Mongo fan. We use a lot of it, but as an analytics tool, it was a problem because you're having to convert that schemaless infrastructure into something that has a schema, so the standard BI tools could work with it. So that was always a very grating point. So being SQL compatible was just number one. I've seen a lot of Hadoop projects that became huge money pits, and those projects have a purpose. I think that there is a place for that, but in our technology stack, it's just we wanted to be lean and mean, and moving into something like Hadoop or other technologies just seemed to not be our skill set, and would have required massive retraining and millions of dollars of additional cost for our scale. The reliable streaming ingest. We stream millions of events every day or every hour that need to get picked up and reassembled. So we wanted to make sure that it was reliable, getting data in, and simple to get data into the warehouse. So there's a number of ways that Snowflake makes that straightforward. Scalable. We're at a massive scale and growing all the time. So we had to have something that was going to grow with us, and we could start small. So we literally started super small. We did a 2-week proof of concept and threw all of our people on it and said, hey, in 2 weeks we can't provide value to the business, then we'll look at something else. So we stood up a small warehouse, had a use case, and we were able to accomplish that in 2 weeks. So scalability-wise, we were then able to take that concept and scale it out with additional data sets over time and re-architect it a few times, and it just keeps scaling with the business as we've rolled it out. Zero infrastructure, going back to some of these other alternative technologies, it was very daunting to think about what it would take to build everything if we had to provision all the servers ourselves, manage all the issues. I've seen it, we've lived it, and we wanted to go whole hog on a zero infrastructure approach this time. So that was a key thing, to just focus on our business problems and not on database infrastructure needs. I wanted to convert our team into focusing on the data and not on the hardware. Dynamic sizing, absolutely. I don't want to get to a limitation in my warehouse where I have to, bring it down and resize things. I just want it to grow organically, and I want it to grow elegantly over time. Certainly there's always going to be improvements we can do in aggregation tables to make queries run, but I don't want to run into physical boundaries and limitations based on volumes and provisioning of my disks. And the data lake and warehouse. We wanted an approach that would cover both data lake and warehouse, if not now, in the future. And since we're an event-driven shop with microservices, we wanted a place that we could just start pumping in all of the events. And maybe we would only need our warehouse to see, or we would only expose a percentage of those. But we knew it was only time before more and more of those events needed to be exposed to our business users or our technical team to diagnose any problems. So we really wanted that place to just dump events and then, as needed, expose them over time. So these events, here's an example on the page of a JSON object that we create. This visit object is, it's got everything about a potential visitor, the browser they came in on, all of these little details that come with a visitor, right? Many of you probably have websites that would have a visit information about someone, the publisher, the campaign, everything that they're seeing, and names. So this visit event is just one of 50 different types of events that and more all the time, that we want to gather into the lake, if you will, and into the warehouse. These are currently on Kafka topics, and we subscribe to those topics. The trick here is each event adds more to the mosaic of describing what that person did and saw and the decisions that were made by the platform. So all of the microservices working together, provide this really nice, elegant experience for the visitor, what questions they see, what attributes were gained, what campaigns were recommended, and what so between questions and advertisements, what the experience looked like. But we are really having to evaluate, did we make the right decision at the end of the day? And so having a data lake of all these events is a desirable thing. Because we never know in the future when we're going to want to go backwards and look at all the events and string together what did this visitor or a million visitors that were just like him or her see and experience, and did we make the right decision? So we think of it as just a mosaic, and each of these events is a piece of the puzzle. And if we throw together 10 of these events, we get a great picture. If we have 50 of the events, right, it is even more rich, but sometimes too much. So that's the foundation of our dimensional warehouse, are these events. We have a data pipeline architecture that is very simplistic in my view versus previous warehousing systems and ETL jobs that we would run to ingest data. The way we do it is over on the Zeeto ad network, our microservices are creating events into Kafka topics, and we have another service that's running Kafka Connect that pushes JSON into S3. And so those JSON documents are aggregated, not really aggregated, but just consumed and condensed into buckets in S3. We run a Lambda process to do some work on the JSON, which is real simple. And then that next S3 immediately goes into a product from Snowflake called Snowpipe. And Snowpipe streams the data in reliably through SQS into the tables that make up our warehouse. So Snowpipe allows us to combine the events and do any of the joins that need to happen before they're added to the tables. So very simplistic in being able to go from this complex event environment into a table, and each of these tables becomes something that we can put a BI schema on top of and expose to our internal users and external users via BI tools. So the event visit campaign table would be a combination of a visit event plus the campaign event or campaign considered event, and the visit question would be a table of the visit event combined with the questions they saw. And sometimes we bring all that together, like the last one there, the visit question campaign lead event or table, being a composite of 4 different event types. So by doing that, we can come up with these very rich views of the experience for that visitor. So we are completely serverless. We have turned off all of our old ETL type jobs, at this point. We used to use Pentaho, Kettle, and other types of tools, and cron jobs, and EC2 servers, and that whole rich architecture is now the thing of the past, and we're completely either Snowflake and Snowflake with Lambda running on AWS. So we want to make sure that all of our aggregations and calculations are done inside of Snowflake. So if that means working on raw data, converting it into something else in Snowflake, we push all the functionality, all of the heavy lifting down into Snowflake. So we don't bring back data into Lambda. We just execute commands, whether that's on, based on triggers or based on schedules, but all done through Snowflake CLI commands. So we just want to take advantage of Snowflake's native compute power, and we don't want to move data in and out of Snowflake. We just keep it all there, use, if it's temporary tables or raw data, moving into, manufactured data. So the Lambda functions, this one, here's a little example here, is one in Python. We've also done them in JavaScript, but Python seems to be the team's tool of choice at the moment. They're very simple to execute a command, as you see there. The query itself is embedded as a string variable, but you can imagine that variable there just being put your query of choice in there, and it would execute. So this has been a good shift for the team, and so getting them trained up on AWS has been fun, and everybody feels on the team that they've learned a lot of new skills, and they're very transferable skills. So the impact so far has been great. We've repurposed a lot of the team members to really focus on the data. By reducing our infrastructure, we spend far less time worrying about servers and size and running out of space and dealing with all of those considerations and speed. All the data is now available in I'll call it our lake. There's lots of ways to imagine what a lake looks like, but in my mind, as long as we're putting all of our events in one place and they're available, that's a lake. We're taking advantage of the per second billing that Snowflake offers. So we shut down things after, we run one of those Lambda queries and we shut down the resource. So if it only takes 5 seconds to execute, then, we're only using 5 seconds of credits. So that per second billing cut our credit usage. Before per second billing, it probably saved us 25% of our credit usage. So that was a great enhancement last fall. We've scaled tremendously on the visitor load side. The impact is just hard to imagine doing it without Snowflake, and all the things and the speed at which we're able to run now, especially with the items that we're looking at implementing or in progress, sort of on the what is next. And the what is next, moves so fast. When I wrote these slides, these were what is next, and we're now kind of in progress launching these right now. We're launching anomaly detection, with some straightforward linear regression models that are all native in Snowflake to identify, trending and then predict the next day's behavior, and then see if the next day is what we think it's going to be, so we can alert our advertisers, our publishers, if they need to take action. We'll be moving that into more and more anomalies that we want to act on. So our team is spending a lot more time doing statistical analysis and putting together the right linear regression models, working on the data instead of the infrastructure. We have launched a pipeline for training our machine learning models. that was very straightforward, just being able to write a query right from Snowflake from our warehouse, populate all the features that our training model needed, and write that up to Snowflake and pick that up with AWS SageMaker. So our pipeline is went from non-existent to running in 2 weeks' time and in production. So very fast, and now we're just iterating on additional models. So Snowflake is a real critical part of our training data set at this point. We're in the middle of doing a lot of data discovery. As I mentioned, we want to understand what is it that our data is telling us about how the system's performing, the decisions we make. So we're investigating our data every day, looking for trends, looking for anomalies, looking for key indicators that we can then institutionalize, or maybe it's a bug fix. But we really want to understand this whole bid, this auction process, and why is somebody winning, why is somebody losing, is there anything that either party did to affect that, and how can we help make the right decisions. And then we're busy with more Lambda functions that are going to drive expanding more warehouse aggregations to meet the needs of our business. So as we get more and more into the next generation of our business, people want to see more data, more aggregations, more higher order statistics in the BI products that we use, and we just keep expanding those as they need. And typically, our turnaround time for a new dimension in the warehouse, is not much more than a couple hours or maybe the next day. So big impact there. And that's all I have. So I think we're done with that.
Well, wonderful, Matthew. Thank you so much. And we're already getting some questions in, but just as a reminder for everybody, at the very bottom of your screen, you'll see a blue QA button in the On24 platform. You can click on that and then type in your questions to be able to submit them to us, and then we will answer them. So, Matthew, the first question that we've gotten in today is, what format are you ingesting the data into Snowflake through Snowpipe? Are you putting raw JSON into Snowflake, or do you tabularize it first with Lambda? Difficult word to say.
Yeah, no, that's perfect. So we are a little of both. We do ingest raw JSON into Snowflake where we haven't made a decision on what the table structure might look like. And JSON works quite well in Snowflake. We did all of our initial prototyping with raw JSON, just in a single field in a table. But once we decide to take that JSON and use it with our BI tool, then we make the decision of how to tabularize it and flatten it typically. So we don't do it in the Lambda function. We do it actually through Snowpipe. So that's the other huge benefit of the ingest, is we do our flattening at that point. And so we just do a little bit of our Lambda function in S3 just does a little bit of tweaking on a couple of our array structures that aren't very nice before we pass it on to Snowflake.
And that's really interesting. So would you say, I mean, this is just me asking this question, by the way, but would you say that gives you some less brittleness as you're ingesting data? Like you have a fair amount of flexibility despite the fact that you have these operations going on in the background as you're loading it? Yeah,
I think it does. It definitely keeps it from being brittle. I mean, we're bringing in Kafka is our schemas are fairly tight when they come out of the microservice. So when we bring them in as JSON objects, we don't have a lot of data change going on or schema change going on. So we don't have to deal with too much change. But when we get it into Snowflake, we now have the ability to either always go back to the raw, or we can look at the tabular view. So if we didn't bring in some leaf of the JSON because we didn't think it was interesting at the time, we always still have it, and we can go query it and play with it, and then we can make a decision if we want to start ingesting it going forward, or or even re-ingest it in retro.
Yeah, no, that makes sense. So one follow-up question here to that one is, do you create a snowpipe for each table, or do you just have a single snowpipe that splits into multiple tables?
Yeah, at the moment we have a single snowpipe that splits into multiple tables. Yeah, great question. So you have a lot of flexibility in snowpipe of how you want that outcome to happen. And so you have a source and a destination, and then you can do some logic in there to your joining together different data.
True. And of course you always maintain the flexibility to batch load data in the traditional format as well. Do you guys take advantage of that in any way, or is it all of your data being loaded through snowpipe?
We do bring over data as well from Postgres. We have another data source that is, not our microservices events, but just the, what's the current state of our, if we administer a campaign or a publisher's current state, we bring that over, and so we attach that current state of the campaigns and publishers, advertisers to the documents, and we can join to those tables. So we bring those over as well. It's not over a lot of data, but we bring them over in the traditional way. Probably I think we bring them over every five minutes right now.
That makes sense. So here's a fun one. You've talked a lot about the benefits of Snowflake and the ease of migrating and optimizing the product. But what about the difficulties? What was the difficult thing about using Snowflake and migrating to Snowflake?
Okay, so, gosh, the most difficult thing, I think to be honest, I don't mean to be flip with this answer, but it was kind of we overthought it a little bit. I think a lot of us, were trying to make it harder than it needed to be. So overthinking how we traditionally approached, how documents got stored, how indexes were handled, how clusters were managed, and micro-clustering, and just thinking we had to engineer the solution instead of just assuming it was going to work. So I think we spent a lot of time kind of in our old roots of boy, we got to understand how everything's going to get stored, or this thing's not going to work. And if at the end of the day we know we spent a lot of time there we didn't have to do. So it's kind of an odd, weird answer, but honestly, we had multiple iterations in this over the past year. We brought in raw JSON day one. We queried the raw JSON. We provided business value within 2 weeks without coming up with tables. Then we built some basic tables around our JSON structures, and that lasted for a few months, and we were able to get to sort of a beta stage with our entire new product offering. Then we decided, okay, that's great. Everything's working great. Let's take the next step. Let's roll out a more traditional warehouse schema. And how do we flatten all this data? How do we merge all this data? And so we've been through kind of 3 iterations, and now we're just more of a fine tuning. We keep adding data, but I think we've got a good structure at this point.
Makes sense. So this is a good one, and it's actually a question that we get from multiple people. We've gotten from multiple people over the years, and what is the volume of data that you guys are dealing with, and what is the size of the largest table that you're querying with your BI tools?
Okay. Let's see, I don't have the numbers at my fingertips here, but let's see. We're probably dealing with data volume. So, we deal with probably a couple thousand events per second flowing in from the microservices into the system. That creates, a couple million rows a day. So extrapolate that over the population of some of our tables. So it's hundreds of millions of rows. I'm trying to think of actual, bytes. I don't have it off the top of my head, but these are non-trivial size tables. Some of these loads used to take, in our old system running on MySQL, these queries would take, 20, 30 seconds up to a minute, and they're in milliseconds now.
Yeah, and
by the way,
anecdotally,
I'm sorry, go ahead. Okay, so I was just going to add, we constrain our resources in Snowflake. So one of the cool kind of things we do is we don't run on the biggest warehouse instances. We try to run on the smallest warehouse instances that we think will work until they don't work. So we constrain our workloads because we want to break knowing that we have something bigger to go up to build up to. So we'll run on micros if our workload will run on a micro. And then we'll scale it up to the bigger servers. And we don't do that just to be cheap. I mean, we do that because we want to self-constrain our CPU usage and basically, inflict on ourselves the pain as if it was, in some instances, so we know we can scale up with hardware, if you will, instance sizes as needed.
You must be really in tune with the audience, because that was actually 2 or 3 people actually asked that question of how do you deal with having basically unlimited and elastic compute capacity? How do you budget? How do you alert? So, I mean, if you could go actually into a little bit more detail on that, that'd be great. And I mean, are you using alerting? Are you using the features in Snowflake where you can automatically limit or shut off a warehouse if need be?
We're not doing any shut off right now or automated. What we have done, we do look at the usage on a weekly basis. A couple things we've done. Think of it from a cost accounting standpoint. We have lots of groups and teams, different workloads, and we create a warehouse for every combination. So we probably run, 15 or so different warehouses. And we run warehouses specific to prod versus dev. So we know what our workload costs look like, when we're going from a load test environment to production. We know what our analysts use versus our production resources use. We know what our external customers are using when they query through queries that are coming in through the tools versus maybe an internal resource that's doing analysis work. So everybody is given a warehouse. The data ingest, works on a specific warehouse. So basically, we think of it as cost accounting so that I can look at each of the different workloads because it doesn't cost me anything, especially, in the old days before we had per second billing, you were like, well, maybe I want to stuff a whole bunch of stuff on a single warehouse because I want to use that extra 30 seconds or extra couple minutes and I don't want to get charged for, spinning up and spinning down. But now that we're on per second billing, I was like, well, heck, let's just create as many warehouses to define the costs at whatever excruciating detail we want because there's no penalty. And so that's been a really good way. And when we look at the charts now, we know exactly where our usage is coming from. So Snowpipe, running on its own warehouse is kind of running in the background all the time. And so you can see, and by the way, using Snowpipe is actually still exponentially cheaper than, the old copy statements and whatnot that we were using when they were running on batch jobs. But nonetheless, there's a cost there. And so we know exactly what our data ingest costs are. And then when our Lambda functions run, we know exactly what our ETL costs are as well.
Right, and so I think you alluded to 2 things there, or mentioned 2 things that I think are very interesting. And number one being that Snowpipe, in your words, is really a more efficient way of loading data into the data warehouse. But you also mentioned per second billing, and after implementing that, your cost for warehouse usage, particularly for queries that run for shorter times, has gone down. So, I mean, would you say that your overall, your efficiency with Snowflake from a cost standpoint has increased over time or decreased?
It's probably increased substantially. I know that even though our loads have gone up, right, as we add more data every month and more visitors every month, our actual credit usage, because of all of these features we just talked about between Snowpipe and per second billing, has gone down, I think, at least 25% since we implemented those things in December. So, you know, we've definitely seen more efficiency over time.
It's a great question here, and it's kind of a follow-on to the ones that we were talking about with usage and all of that. But how would you control or limit abuse? For example, an analyst that's running unnecessary analysis.
Yeah, interesting. Well, I believe we could put some restrictions on those warehouses. We don't do anything like that today, so that might be something, Ross, if you've got other things up your sleeve. We're not taking advantage of those things at the moment, though.
Yeah, so just to answer this question, the standard way of dealing with something like that is you would probably create an independent warehouse for individual analysts, and then you could budget out for a given month basically the amount of compute usage that you want to assign to that person and therefore that warehouse. And you can also budget warehouses in groups. So let's say that you have a team of SQL analysts and you want to budget that entire team. You can use a resource monitor essentially to monitor all of the usage in all of the warehouses and then limit it to a certain value. And what's kind of nice about that is that it stops the question from being, about whether or not the analysts are asking the right questions. Because I think, to be fair, sometimes you have to ask kind of dumb questions to get around to the good questions and the focused queries. And it turns the question instead to, how are you using your resources, which is the question that you're really getting at. You want them to be able to interrogate the data and ask questions and do ad hoc analytics, but you're really looking as much as is possible to have them do that in the most efficient way. So it really puts the impetus on the analyst to actually think about the efficiency of their queries and to be as efficient as possible when you use that sort of resource monitor and limitations that you can put on a warehouse. I don't know, Matthew, do you think that's a fair characterization of how somebody would go about doing that? I know that you don't do that exactly, but.
Yeah, no, that makes total sense, and I think we would use that exact technique, once we kind of, I think, move into that realm. So
we have another question about ingestion here. So obviously you're using Snowpipe to pull data into Snowflake from S3, but how are you pulling data from Kafka onto S3? Do you use a tool like SQL to do this, or do you have a custom script? How do the files actually land in S3?
Yeah, no problem. So Kafka, if you look at the open source Kafka, there's a project out there called Kafka Connect. And Kafka Connect you can wire it up to, as a subscriber to topics. And then the other end, you can wire up to write that data into S3 or wherever. In our case, we actually, long story, but we actually do use Avro in Kafka. And then when we push it out to S3, we push it out as JSON. We probably could have left it as Avro all the way through, just something we did early on. And so we actually do that transition as well in our Kafka Connect. Kafka Connect has gone through some good iterations. It used to have a few bugs, but boy, it seems to be pretty spot on now.
It's great to hear. So we've kind of come to the end of the questions that people have put in. So please do feel free to insert a couple more questions. We have a couple more minutes here. But as we're coming to the end of our time here, I just kind of wanted to ask a little bit of a broader question, Matthew. And it seems like what you've built has been a fantastic resource for your team, and you guys are really kind of running at full speed here. But I'm sure that you also have some plans for the future. And we was just kind of wondering if you'd be willing to share, like, what does your analytics look like in a year from now? I mean, what does your usage of Snowflake, how is that going to change?
Yeah, interesting question. So I have to look into the crystal ball here. I think our data science needs are, I think we're at the tip of the iceberg. So using it as a platform for analysts that are doing data science, more and more wiring up to, I just want to say traditional data discovery from data scientists that are, truly trying to come up with hypotheses and prove those hypotheses. That's what I'm challenging my team with every day. And I'm spending a few hours a day, loading data into R, writing queries from Snowflake into R, and plotting that data, looking for correlations, trying to help out our product team and understand what's going on and answer questions and look at new insights. So, I think we're at like I said, the tip of the iceberg of that type of analysis, and probably bringing on more people that can do that, which will just expand our need for Snowflake to have the right data, the right dimensions. Whenever you start on one of those projects, you find, I wish I had this data associated with that data. Let's add more dimensions to the warehouse. So, then that is some event that we didn't need before that is sitting out there in the lake. Let's get that merged in to the table structure. Our data sizes are going to keep going through the roof, so we'll keep pushing the limits. I think that's as we look at more aggregations and looking at performance and working with the Snowflake team. I've recently heard about some of the new features that are coming out in Snowflake, hopefully in the next year. And I'm very, very curious, for materialized views. I just think that's going to be a big deal for us. We definitely have some customers that want to share data or have Snowflake accounts. So I know there's some new things on the horizon with data sharing. So some of our key publishers and partners that we want to provide, be a data broker for those guys, be their infrastructure. So we as a middleman between advertisers and publishers, we're really a data company, and that will become more and more apparent with our these relationships.
Yeah, and I think when you look at all of our customers, really, even people who aren't directly in the data business in the way that you guys are, really are becoming data companies as well. I mean, to me, if I were to answer my own question for our customers as a whole, it's to become more of a data company in a lot of ways is really what the future looks like for them. So I'm sure many of you on the attendee list can identify with what Matthew's talking about there. All right, so that brings us to the end of our office hours. We'd like to thank everybody who attended today, all of your fantastic questions, and of course a huge thank you to Matthew Ferguson, CTO of Zeeto, for sharing your fantastic experience with Snowflake and answering everybody's questions. So thank you.